Today we'll be looking at how to call C functions inside assembly. So this will be an interesting video and let's jump into it. So I'll go ahead and create my file. So name it maybe casm .s. Now as usual, first of all, what we have to do, we want to use the printf function. So let me use the printf function to print out a string. So first of all, we have to define the string that we want to use. So I'll go ahead and declare in the section data. I'll go here and maybe use msg. Then I want 1 byte. Maybe let us print hello world like that. Then I will add a 10 to indicate a new line. So 10 is a number in the ASCII table, meaning print this in a new line. Then finish with a 0, meaning that this is a null terminated string. So this will tell the assembly or the assembler where our string ends. Then we don't have to calculate the string length because the printf function will do all that heavy lifting for us. So we'll go ahead and define our section text where we are writing our source code. Now, in the previous videos, we have been using the global start, but when it comes to calling C functions inside assembly, you have to use main because the GCC compiler looks for this symbol or label instead of the start. So you just declare global main. It is a direct translation to the int main in the C programming language. Now, before writing any other code, we have to import the functions that we want to use. And in our case, we want to use the standard function for standard output, which is printf. So I will use the extern keyword followed by the name of the function. So printf. So we are telling the assembler to go get the printf from the C standard library. Then also we will use again the extern exit function. So this is for our exit. If you can remember, if you know some C, we have a function called exit, whereby we pass our source code, maybe 0 meaning returns it all, or -1 meaning that the program has exited with an error. So with that, let us go straight and use our main symbol. So our main symbol like that. So what are we doing in this case? So we have to push some values into the stack, then call the function, which will first look for the values inside the stack, take the value and print it. So maybe I might do some illustration for understanding purposes. So a stack is just a data structure or a memory structure that stores things in a stack form. So and it follows these rules. So the first thing will be the last thing. No, I'm sorry for that. So the last thing will be first out. So LIFO. So it follows the LIFO standard. So you can use this analogy by, you can maybe look at plates or a stack of books. So when you stack books on top of each other, the last book that you have placed on top will be the first book to take out from that stack of books. So the stack works similarly. So we will push the string hello world, and then we will call the printf function, which will get the data. When you call it, it will go to the stack and look for what is inside the stack, takes what is inside, and then does the printing. So let us see that part. So first we have to push something into the stack, the value that we want to be printed. So we use the push keyword. We haven't seen this before, but it's an introduction. So the push keyword, what it does, it pushes data onto the stack. So what are we trying to push? We want to push the message. As simple as that. Then after doing that, you make a call to printf. Remember, if you're using printf, you have to import it over here. So it will not allow you to use it if you have not used the external printf. Then what this two lines means that we have pushed a value inside the stack, then we have called this function. So this function will go back again to the stack, look for something to print, or the value that you have pushed, the latest value that you have pushed, then takes the value, then puts inside the printf, then prints the value. Now again we'll use the push again, and we'll push the digit 0. This is our status code. If we had an error, we can do a non-zero like a -1, but this is like we are pushing 0 to the stack again. Then we call the exit function. So the exit function, again, it will go back to the stack and see what value is on top of the stack, then takes it, prints it, then clears the stack. So hope this is clear. Then after that, this is all that you have to do. So let us compile it. I will go ahead and use gcc. First we have to assemble it using nasm -f, and before going on, there is some libraries that you need to have installed inside your machine, mainly the GCC compiler, the 32-bit version of the GCC compiler. So, and you can install it using sudo apt install gcc-multilib, like that. Then another one that you will install is the G++, again multilib, like that. Then you just install it like that. So I had installed this anyways, so you will see that I have installed it. But if you haven't, you had not installed it, just use this command. So sudo apt install gcc-multilib and G++multilib to get the GCC and the G++ compilers, the 32-bit versions of that. Now after doing that, so let us now assemble it using nasm -f, so followed by our name. So it was casm -o, then we generate our object file, so casm, like that, .o. So what have I not done? So I have not included the elf, the format, so elf 32. So let me do this. So elf, so format will be elf 32, followed by the name of our source file. Then we generate our object file. So it has assembled, so we have the object file. Now this step is where now we use the GCC compiler now to link the program and get our executable. So what we'll do, I will use GCC followed by the no-py flag. The no-py flag means that we are telling the computer not every time we run our executable, it should run in the same memory address, because in modern day operating system, the py or the py instruction tells the program to, every time you run the binary, it will run into a different memory location. If you run again into a different memory location, hence strengthening security. So this py or something independent execution is useful for operating system for security purposes, meaning that a hacker may not exploit one memory location if he or she knows where the program will always run. Because if the py is enabled, it will run. If you run the first time, it will run into a different memory location. If you run again, into another memory location, meaning that it is unpredictable. But we want it to run in the same memory location. Then we have to use the -m32. So we are telling the GCC compiler this is a 32-bit program or object file, followed by our object file, which was csasm.o. Then now our final executable file or binary, which we'll name CSM. So you'll see a warning here. This is a warning, but it has already produced our executable. If you can see, we have this executable that has been produced, and we can go ahead and run it. You can see now it has it has an output, but we have a warning here. To make the warning go here, you can see, if you read to the instruction, they are telling you you are missing a section called .note.gnu.stack. So copy this, go back to your source code. So where is our source code? And maybe put it right here. Then don't forget to use section. So this will clear out the warning, but it doesn't make our program not compile, as you can see. So let me run it again. So let us assemble. So you can see it has assembled. Let us now link and produce. You can see now the error is gone. So if I run again, you can see we have our hello world printed from the printf function from the C programming language. So just a recap. So what you have to do, maybe what we have done, we have declared a string in the data section. Then what we have changed here, normally we have been using /global _start. Now we'll be using, if you're using or importing some C files, you'll be using the main symbol. Then over here we pushed something into the stack, then called this function, the printf function. And in order to get access to the printf function, you have to use the extern followed by the name of the function that you want to call. Then use the call directive, the printf. So the program will halt, go to the stack, take the value, print it, then pops that value from the stack. Then we have this push again, pushes 0 to the stack. Then we call the exit. Now the exit has the program, goes again, takes the 0, and now we get our status code. If you want to confirm, maybe I can put something like 100, and then let us compile. Let us assemble first. Let us link it. So if we run CSM, then we use echo to see our status code. You can see Now this is our return or our exit, our status code. So for now we have used the standard output function, but in the next video you'll be seeing how to call your own custom functions from the C programming language. So if this has been helpful to you, like, subscribe, and leave a comment. So let us do some practice on this, and then we'll go ahead and advance on our skills. So thank you, and see you on the next video.